Okay, what we have here is we're going to be doing some trig, and we're going to be talking about how to understand and simplify expressions using inverse trig functions, all right, or expressions. And so what we have right here is we're going to find the exact values of these expressions. And what we have is a sine of arctangent of 3 or 4, and I have 3 examples right here for us to do. So if you want to try these examples, and I'm going to go through them just a little bit, that would be great. All right, well, for those that, they can start off with example number 1. The key thing to understand is that when you take the sine, you're always taking the sine of an angle. And if you recall, what you get is that you have the sine of an angle, and that equals a ratio. Okay? And so what we have right here is that when we have the arctangent of 3 over 4, remember arctangent, this is our ratio, and we plug it into our arctangent, and what we get out is an angle. And so what we're going to do is figure out, okay, what is the sine of the angle, all right, ratio going to be? Well, since in the arctangent, they already give us the triangle that we're going to be using, which is a 3, 4 of arctangent. So what we're going to do to help us figure this out, if you're going to draw a little triangle, this is arctangent of 3 or 4. Well, arctangent can either be in the first or fourth quadrant. And since it's positive, we know it's going to be in the first. So here's the angle of this arctangent. Now, tangent is TOA, so opposite 3, adjacent 4. And what's going to happen now is now we're going to figure out, okay, what is the sine of this? Well, we have a 3, 4, 5 triangle. And so when we have this, using the angle we get from arctangent, which is this angle right here, we will have a ratio of sine of 3 over 5. So our answer to this one, our simplified answer, is going to equal 3 over 5, because that's the sine of the arctangent of 3/4 of this angle with this triangle. All right, let's try this one. Secant. Well, once again, secant of the angle that gives us the arcsine of 4/5. Okay, so what is this? Well, doing a triangle again, sine can either be in the first or the fourth quadrant again. Because it's positive, sine will be in the first quadrant. So the arcsine of 4/5 will generate this angle that we don't know. But we do know a triangle because sine is opposite over hypotenuse. So I'll put 4 or 5. All right. So if we have this, 4 or 5, well, this has to be a 3. Very similar triangle over here. But now we're finding secant. Secant. Now using of this angle, what we know is secant is the reciprocal of cosine. So that's going to be hypotenuse over adjacent. Hypotenuse over adjacent is 5 over 3, and that would be our answer. All right? Well, now let's try this one. We have arcsine of -3 over 4. Well, arcsine of -3 over 4, let's try another one. Okay? So where would this be? Well, since this is negative, it's either going to be the first or fourth, but sine, all right, is negative, so it's going to be down here. So we're going to have a negative angle here. What triangle do we have here? Well, this is going to be sine is opposite over hypotenuse. And so it's going to be -3 right there. So it's going down. And now what is this side? Well, we'll call this side B or A. Well, this is not a, all right, 3, 4, 5 triangle because this is the hypotenuse. So we're going to use Pythagorean theorem to help us figure this out. I'll move this down a little bit. And so we have 4 squared equals -3, that quantity squared, plus we'll say this is b squared. Solving this, we have 16. This is going to equal 9 plus b squared. And so we subtract that to the other side. So we have 7 equals b squared. And so b is going to equal the square root of 7. Okay, so the triangle for the angle that will generate -3 over 4, all right, now we're asked to find the tangent of this angle, of this particular triangle, of arcsine of -3 over 4. So would that be? Well, tangent is TOA, opposite over adjacent. So this answer is going to be -3 over the square root of 7, which is the same thing as -3 square root of 7 over 7 if we simplify. All right? Okay. So that is one way we can solve, all right, some varying degrees of, all right, expressions involving inverse trig functions, okay? Or I should say involving inverse trig, yeah, inverse trig functions. All right, well, we're going to do some more videos in just a little bit.